Welcome friends. Here we are about to start MCQ number 5. Let us read the MCQ. A body of mass m is attached to the lower end of the spring whose upper end is fixed. The spring has a negligible mass when the mass is slightly pulled down and released. It oscillates with a time period of 3 seconds. When the mass m is increased by 1 kilogram, the time period of oscillation becomes 5 seconds. Then the value of m is in kilogram. Then options below which are given are A 9 by 16, B 3 by 6, 3 by 4, C 16 by 9 and D 4 by 3. Amongst these all options, which one is the correct, that we are going to decide. But while knowing the data which is given, let us see the solution. The solution is before you, that is, here it is T1 is equal to, initially it is 3 seconds, okay, and T2 is equal to 5 seconds. What about the masses? Initially for this one the mass is m, and here the mass is m plus 1. So let us solve this one. Now if we know the equation regarding the time period and the mass, we have the equation, that is T1 is equal to 2 pi under root of m by k. This is the formula which is known to you, and if this is the formula for the T1, give it as a equation number 1. Okay, this is equation 1. And later on, if we are going to take the T2, that time we know very well the mass has been increased by 1, so its equation it is given by m plus 1 divided by k. This is equation number 2. If it is so, dividing equation 1 by 2, let us divide the equation. Dividing equation 1 by 2. If we divide this equation 1 by 2, then we have this. We say that T1 upon T2 is equal to 4 pi square, 2 pi, instead of that one here it is 2 pi upon 2 pi, here it is under root, values are under root of m by k upon under root of m plus 1 upon k. The similar terms get cancelled, obviously k also get cancelled, and the new factor which is remain is we say T1 upon T2. But before that one, if we square that one, T1 square upon T2 square, which is given by under root of, or instead of under root we say that it is m upon m plus 1 outside the square root if we are going to square this. Then after squaring that, if we substitute the value and about to get the value of m, so here T1 is already given, that is 3, and 3 square is 9. 9 divided by T2 is a 5, 5 square is 25, and here it is m upon m plus 1. Okay, if we cross multiply it, 9 into bracket m plus 1, which is equal to we say 25m, and if we multiply inside the bracket, 9m plus 9 is equal to 25m. If it is taken to the right hand side, 25m minus 9m, and this is only the 9 factor which is remain. And after solving this, here it is 16m and this is 9, so m is equal to 9 by 16, and this is your expected answer. Then choose which option it is correct. See this one, if we go up side we got we say 9 by 16 means this option is correct, that is option A. Option A is correct. Option A, 9 by 16. What about the next? Let us solve the next MCQ, that is 6th MCQ. Let us solve this one. Before solving, let us read out that here the time period of oscillation of a mass m suspended from a spring of a negligible mass is t if along with its another mass m is suspended. The time period of oscillation will be option A t, B t by under root of 2, C 2t, and D under root of 2 into t. Among this one, which one is the correct, that we will decide. Before that one, what are the factors which are given here? We say that if regarding the solution, if we are going to observe for the t, corresponding mass is m, and for the t dash we consider next time period, the mass is 2m. Then its equation previously as we saw, that is t is equal to 2 pi under root of, we say m by k. And what about this t dash? T dash is equal to 2 pi under root of, we say 2m upon k. This is equation number 1. This is equation number 2. Dividing 1 by 2. Dividing 1 by 2. 1 by 2. Then t upon t dash is equal to, if we need to get that, 2 pi divided by 2 pi into, we say under root of, is here it is m divided by k, and here it is under root of 2m divided by k. Similar terms get cancelled. After cancelling the similar term, m is also get cancelled. And if we square this, or we say instead of squaring, just a t divided by t dash is equal to, we say 1 upon under root of 2. If we solve this, we say that t dash, if we take the reciprocal of that, it is just under root of 2. See, observe this one, taking the reciprocal. Then later on, we got the relation, that is t dash is equal to under root of 2 into t. This is the one of the relation between these two we got, and which option it is correct, that we will decide by knowing all that. Here it is square root of, here it is the option D, it is correct. Okay, option D, square root of 2 into t. Okay, let us get the knowledge about the next MCQ. MCQ number 7. A particle is executing simple harmonic motion of an amplitude A along the x-axis about A along x is equal to 0 when its potential energy equal to its kinetic energy. The position of the particle will be A by 2, B A, C A upon 2 under root of 2, and a D option A by under root of 2. Before knowing, the initial thing is this one, what exactly is the displacement of that if kinetic energy is equal to potential energy. The first condition that we are going to know, the condition is this one, kinetic energy must be equal to potential energy. Then what is the displacement at that point where kinetic energy and potential energy are equal? This is the most important one. As we saw the graphical representation in that one also, kinetic energy and potential energy, they intersect at a common point. and what exactly is the displacement, that is very important. As we know the kinetic energy equation, in case of simple harmonic motion, that is half of m omega square in bracket a square minus x square is the kinetic energy. And what about the potential energy? That is half of m omega square x square. The common term get cancelled, and a remaining factor, it is a square minus x square is equal to x square. Okay, then later on a square is equal to x square, and this it taken to the right hand side, it will become plus, that means it is again x square, that means a square is equal to 2x square, and x square is equal to a square upon 2, and x is equal to a upon under root of 2. Then displacement, it is given by, okay, this much. So which option it is correct, that we will decide. Here it is, the last option, D option, it is correct. D, here we say a upon under root of 2. This option it is correct. And let us know about the last, that is 8th one. A particle executes a simple harmonic motion with an amplitude of 5 cm when the particle is at 4 cm from the mean position. The magnitude of its velocity in SI unit is equal to, that is, this is most important, the magnitude of velocity is equal to the acceleration. Okay, then its time period it is, then we need to calculate the time period. So options below are A 7 pi by 3, B 4 pi by 3, C 3 pi by 8, and D 8 pi by 3. Let us know the solution regarding this one. Let us understand the diagram first. For that one I need to draw one diagram. Here it is the straight line before you, particle performing simple harmonic motion, and this particle, when it performs a simple harmonic motion, it is having its mean and extreme positions. This is your mean position and this is your extreme position. Okay, extreme position. This is your extreme position. If it is so, then I'm going to take this as a, we say, distance covered from, means say amplitude is given, already the amplitude it is given. Okay, amplitude is, we say, here amplitude is A is equal to 5 centimeter. Okay, here we are going to be right here, amplitude A is equal to 5 centimeter, and the particle existing at particular point at a distance x is equal to 4 centimeter. Now this distance is a 4 centimeter, we say. Okay, from the mean position. If it is so, then I am going to equate the condition, that must be here the acceleration or velocity is equal to acceleration in simple harmonic motion in SHM. SHM, this is the condition. Then means velocity is equal to acceleration. If it is so, then I am going to write here, it is formula for the velocity, already we know very well, omega into under root of a square minus x square, which is equal to omega square x. As we know, a is equal to 5 centimeter and displacement from the mean position is of 4 centimeter. Then we need to calculate the time period, that is t question mark. Then we substitute the value. As we know, this omega, one of this omega square and omega it is get cancelled, only omega it is remain. So after squaring, or we say squaring, here it is a square minus x square is equal to here omega square into x square. Or instead of writing that one, if we are going to again reconsider the fact, that is under root of if we substitute the value of a, that is 25. How 25? A is a 5, so square of that one is 25, and 4, that is 16. So substituting, it is omega into 4, displacement is 4. If we substitute this and we got the value, that is we say under root of 9 into omega into 4. Under root of 9 means 3 is equal to omega into 4, and omega is equal to 3 by 4. If we substitute omega is equal to 2 pi upon t, then 2 pi upon t is equal to 3 by 4. And what about the next, that is t upon 2 pi is equal to 4 by 3. Then t is equal to 2 pi into 4 upon 3, that means t is equal to 8 pi by 3, and solution is this one. So which option it is correct, that we will decide. 8 pi by 3, this option D it is correct, that is D option, 8 pi by 3 it is correct. Thank you.